Open na ako, IB. Okay.
So, good evening, everyone. Okay, so I would like to ask, your consent that I will. Okay, so I would like to ask your consent about the recording of today. Okay, that I would like to publicly put in YouTube for the benefit of many people. Okay, so that will use the IFN transport. So if any of you disagree, okay, you can simply close your video and you can also rename your name to be private. Okay, there is no problem with that. Okay, and then before that, I would like to ask about the makeup class schedule. So if we agree, we, um, we can schedule a makeup class because we have so many holiday. Okay, but if not, okay, then all the unfinished material in Moodle will be part of the self-study. Okay. So my question, do you consent? Okay, so you can close your. How about the makeup class schedule? Is there any discussion among you?
Sure, if you're okay, Abby,
Okay.
go.
Okay, guys. Sige, go. Ikaw muna.
I'm not sure about the schedule of others, sir. Are you referring to next week for December?
Yeah,
Anytime next
it's
week?
okay for next week. Yeah.
Okay. Abby?
So when is the date of next week? Because I think we are not allowed on 22, right?
Yes, sir. That's the Lantern Parade.
Right. So how about 19 or 20?
Sir, I'll make a poll with our in our group chat, so I can report it back to you today.
Okay.
The choice is 19 and 20, 6 to 9 p.m., sir.
Yes. So 19 or 20 or 21 if you want. It's up to you.
Okay, sir.
Yeah.
I'll check
I'm
with
not
them.
sure if 21 is allowed. The last part is 21 or 22.
The Lantern Parade, I think, is 22, but I think towards 21, 22, that's already Christmas party season in the
Oh,
Philippines, sir. So.
right. So in that case, 19 or 20. Yeah. So if you agree all, then we can make it. Okay. If not, then we will see on January. Okay. So 20. Oh, Lantern Part is on 20.
Sir, never mind. It's 22 po. I mistyped. It's 22.
Oh, okay. Right. So these are our schedules. So optional one makeup class in December. So these are the topics that we'll discuss. Okay. And then we have January 4 as the project and paper due date. And then January 5 as the last class. Okay. So in this case, you will do a project presentation again in the last moment. So for today, you will do a progress report, right? and then we will discuss about the IFN. So, do you want to start with your progress report?
Sir, before we start, can you also discuss regarding the coverage of the final exam? If it's going to be
The,
the entire coverage or just the items discussed after the midterms?
mm, so the coverage of the final exam usually cover everything from the beginning until the end. But what do you think? I would like to listen to what is your suggestion on that. So yeah, if nobody make any suggestion, then shall we make the final exam coverage from the beginning until the end?
Maybe Abby, sir, can include that also in the poll
Ah,
and
okay,
vote on it.
okay.
Okay, sir. But just a reminder for everyone, I have a poll in our Viber group. So far, sir, we there 7 people already answered and 6 persons decided to have a makeup class on December 21. I'm just waiting for the others to
Okay.
answer.
Okay. About the progress report, you can uh, start to present probably. Don't worry, the progress report recording will not be put as public, so you don't need to worry. Okay. Only the in the part of the lecture later about IFN. So you can still open your video at this point.
Maybe Andrea and I can go first, sir.
Okay.
Okay. I'll just start sharing my screen. It's disabled, sir.
Wait, I will put you as co-host. Right. Okay, so you can.
Okay. Wait, sir. Share screen. Yeah. Okay. Can you see the screen now? Sir? Yeah.
Okay.
Okay. Uh, mm, okay. Basically, our topic is about the analysis of the introduction of protected bike lanes in Makati CBD. As we mentioned before, cycling should be a safe journey for cyclists, and in Metro Manila, there are 1 in 3 households that own a bike, and there have been, as of 2021, 2,397 cyclist accidents. 33 have been fatal, and there is the presence of 430-kilometer bike lanes in Metro Manila. And the Philippines has a 7 million budget for additional 470-kilometer of bike lanes. There have been issue, there have been mention of bicycle lanes being turned into shared lanes, especially with motorcycles, especially in EDSA. But issues have been raised that this compromises the safety of the bikers. So our study area is the Makati Central Business District, which is bounded by EDSA, Osmeña Highway, and Hilpuyat. So the Makati CBD attracts thousands of trips across Metro Manila and nearby provinces, and public transportation routes run along the three main roadways bounding the area. The presence of one Ayala terminal along EDSA also serves as the transportation hub connecting the CBD to the rest of Metro Manila and nearby provinces. So this is basically this is EDSA, this is Buendia Avenue, and this is Ayala, and this is the Makati CBD we are talking about. So cycling is a main form of transportation for workers in the district, and the survey said that bike to car owners is at 4:1, and other statistics also include there were 100 plus thousand cyclists in EDSA, 75% of cyclists bike to work, and there are well-maintained bike lanes along Ayala Avenue. Bike lanes are present in the three main thoroughfares surrounding the Central Business District. And then there were protests against the proposed removal of bike lanes and the shared bike lanes. So our objectives is to analyze if the introduction of a protected bike lane system along Buendia or Hilpuyat Avenue is feasible, and then does the introduction of the bike lane worsen the traffic flow in the area, analyze the possible effects of the implementation of bike lanes in terms of transportation modal split. The study is significant because if lanes are proven to be a positive change in the area, it will help entice and move more people to cycle instead of using private cars in the area, and it will also lead to health and environmental benefits. Promote multimodal use and lead people to use public transport in lieu of private vehicles. Hence, it will also lead to easing traffic congestion in the area. This is our basic study framework. We will take into consideration the street network structure and the traffic volume, and then we will use modal choice computations and IFN. The analysis will then be checking interconnectivity, and then we will add a simple cost-benefit analysis, traffic flow, and also we need to add also here the growth. We will also have to check the growth factor in 5 to 10 years and check that also in terms of modal choice and IFN. And then this analysis will help us lead to the conclusion and recommendation. For the methodology, this is the part where Andre will take over. Andre, would you like to share your own screen, or you just tell me?
Sige. I'll tell you na lang.
Okay.
So for the methodology, first, what we did, we did an IFN analysis of Buendia Avenue with two scenarios, with bike lanes and another without bike lanes. Then after that we plan to use a simple modal split analysis and use this modeling using bicycles as alternative to private vehicles. And after that, we also plan to use, although we're still not sure, all or nothing traffic analysis or capacity restraint analysis for further analysis. And we also plan to project growth factor for 5 years and for 10 years. Next. So for the analysis, no change. So the first analysis would be a no change scenario. So IFN will be used for the entirety of the lane with bike lane, and another for IFN with the bike lane. And by doing this, we will find out if they will introduce a potential reduction in traffic congestion and air pollution. And the mathematical models will estimate the number of cars that will be taken off the road if more people choose to cycle instead. After that, we'll analyze with simple basic benefit analysis, and also implement safety issues, health benefits, and I don't know why this is benefits during pandemic, so scratch that. Okay, next. Sorry. Next slide. Okay, so procedure. So for the first procedure we did, we manually plotted the nodes along Buendia Avenue. And the nodes we used were the intersections and road access points along Buendia Avenue. So an intersection we plotted points before and after and after an intersection, and also for road linkages that connect the main road to the more local roads, we also placed nodes there. So in this in for Buendia, we had a total of 40 nodes. Next. So here are the 40 nodes. On the left side of the, you can see 40 nodes that we used. It's labeled according to the road that connects them with Buendia Avenue. So Buendia Avenue is a long road, and for example, for node 1, the first node we used was the intersection of Buendia Osmeña Avenue, the main road, bounding the CBD to the east, to the west. And Medina Avenue is a small local road, and as well as Talo. For the intersections, we used two separate nodes to signal the end and the beginning of an intersection. So as you can see, this is the first part is for the eastbound, and the second part is for the westbound. So yeah, and on the right side, you can see the link ID, the link identification numbers. You can also see the origin nodes and the destination nodes, and the lane capacity, and also the length of link. The length of link basically is the distance from one node to another, and we settled with a max speed of 60 kilometers per hour as is the maximum allowable speed in the road. So for next. Okay, so for the link capacity, we derived from the standard 2000 PCU per hour per lane. And the max speed, as mentioned, is based on MMDA's max of 60 kilometers per hour. So for node 1 to 10, and for nodes 35 to 40, node 1 to 10 and 35 to 40 are parallel each other. So they had 4-lane roads with average width of 11 meters. And so using the 2000 per hour per lane capacity, we derived the total lane capacity to be 8,000 PCU per hour per lane. So for the next slide. But when it reaches Ayala Avenue, there are nodes 10 to 21 and 25 to 25 to what? This should be okay. This should be 35 ata. This should be 35. I'm sorry, but it narrows down into a 3-lane road. So the total lane capacity also goes down to 6,000. And for nodes 21 to 22, it's the filter is the last stretch of road for Buendia Avenue, and it forks into Kalayaan flyover. So the it's only a 2-lane road, about 6 meters in length. So we gave it a capacity of 4,000 PCU per hour per lane. For the terminal links or the links from the end of EDSA and Osmeña, we gave it 8,000 PCU per hour per lane, since the Osmeña and EDSA has 4-lane roads. We assumed 4-lane roads for Osmeña and EDSA Avenue. So next. So we ran the node matrix and the link matrix on an online IFN calculator. So place the load matrix on the here in the link matrix here. So this is what we got. So more or less, this is an representation of Buendia based on the coordinates we gave. So yeah, okay, next. Okay, so from the results, this is the results we got. So the average flow is 3,600. So congestion level at 56%, and network travel distance is average is 0.1675 kilometers per link, and network travel time to be 10.30 seconds. This is assuming max flow. Max, yeah. This next network speed would be 58.85 kilometers per hour. And then the delay 0.2177 seconds per link. So next. So we also got the individual link results to be too many to analyze. So next. So next, we also wanted to find a scenario with the introduction of a bike lane. As you can see in the picture, bike lanes in Buendia are uh, are marked by simple paint line. So on the right side, you can see the bike lane. It takes up approximately half of a lane, but uh, but taking up half of a lane essentially renders the outermost lane unusable for private vehicles, since they wouldn't be fitting in the half a lane. So 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 for the second scenario, we opted to take the whole lane and to separate the whole lane and to take a whole lane away from the IFN and which serves as a bike. So the reason we take it out is because we want to implement a protected bike lane. Protected bike lane meaning that private cars won't be able to encroach on the road on the lane. So by doing that, because it's simply a paint right? It wants to stop a private vehicle from taking an entire lane. Basically, by using a bike lane, we can ensure that the lane is not used by private vehicles. Okay, so for nodes 1 to 10, so a simple what we did was simply take away one whole lane. So effectively lessening the total capacity by 2,000 PCU per hour per lane. So this is what we get. So we just deducted 2,000 PCU per hour per lane per node since it's lessening it by one whole lane. So yeah. Next. Okay, so this is a updated link matrix with the introduction of bike lanes. It's essentially the same, just with different lane capacities. Since the capacity would be since the capacity should be lower, since we did take out the whole lane. This is our results. On the next slide, we can see the comparison of the results. Okay, this is the individual link results for with bike lanes. The next is the comparison. So for the comparison, this is what we got. So the average flow did indeed lessen from 3,600. It did go to 1,800. However, congestion level was this is the results we got from those by lowering the lane capacity for each lane. We got a lower congestion level. And we also got less travel time by not too much, by only around uh hundreds of a second, but the which essentially says it will remain almost the same. And network speed also increased by 500ths of a second, and the network delay lessened by hundreds of a second. So overall, I think that we can say that it didn't uh, greatly affect the travel time and network speed. However, it did affect the congestion level by by lowering the lane capacity of the nodes along Wendy Avenue. So this is are the results. Next. Okay, so for future, we also plan to use a mode choice modeling using bicycles as alternative to private vehicles. The possibility of expanding IFN to cover key destinations in Makati CBD. So not just Buendia, but we'll also make nodes around the Makati CBD, some key destinations like malls, shopping centers, and terminals. And we also plan to
Okay. So is there anyone want to give comments or question to this group? So what's your plan actually? Do you want to put the curve along? Oh, Nina, yeah.
Sir, question lang. Kila Andre and Miss
Mm.
Mary Blaze.
Yeah.
Have you verified the class of bike lane dun po in the study area? Because as you mentioned, you reduce the capacity by one lane. And if the class of the bike lane is shared, because we have the class of the bike lane which is shared for the bicycle and the motorized vehicles. If that's the case, if it is a shared path, shared lane, I think no need to reduce the lane capacity.
Okay.
Yes, uh, we did we did factor in the shared lane. However, uh, shared lanes actually defeat the purpose of having an bike lane in the first place, since it would be it would be motorcycles who will be using them, as we can see in bike lanes in Manila. So we opted to have a protected bike lane, so that the purpose of the bike lane will stand as a safe to protect the safety of cyclists, and thereby we do need to take the entire lane away from motorized vehicles. Did I answer your question?
Okay, so basically you are assuming that you are going to construct a protected bike lane. You're going to
Yes.
separate the bike lane.
Mm.
Okay, noted. Thank you.
Because in addition to that, kasi we actually started with a different topic. We were considering EDSA, but then Sir informed us that it's not really safe to have bicycles in the highway. And then uh, through our literature review, cyclists really do not like to have a shared bike lane with motorcycles because it really compromises their safety. So we had to take out the notion of uh, lane sharing between motorcycles and bicycles.
Yeah. Okay. Guterres, you want to say something?
Hi, sir. Just a question or a comment to the presentation of Ma'am Chu and Sir Andre. Uh, the I think they used a very large capacity for a 60 kph roadway, but maybe they have interchanged the PCU per hour per lane for the PCU capacity of the carriageway, because
Mm.
I saw they use the 8,000. It's too large for a capacity for a lane. So
Hmm.
that's why their congestion levels are pretty low compared to the
Hmm.
actual scenario of Makati. And that's
I
just
see.
one comment, sir.
Okay.
Yeah. So please check again.
Thank you
Yeah.
for that.
Yes. So yeah, I have several comments. So first, if you want to use the classical one, yeah, the classical nothing, you need to have a OD data. But in here, you don't have OD data. What you have is only origin destination of a node. Yeah, is between node links. So the one we said OD data here is between zone. Okay. So in this case, you don't use the IFN. However, the way you use IFN here is a very simple, uh, loop only, which does not include the whole network that you want to cover. So that make me doubt whether your result is actually correct or not. So
Because this is just the initial, sir.
yeah, that's okay. So
It's not all
you can reiterate again, right?
there.
And then uh, you can use half a lane because it seems your uh, reduction of the capacity is only 2.5, isn't it?
Yes, sir.
So you can reduce instead of one lane, you can reduce based on road width. So you can simulate that reduction of capacity, right?
Okay, sir. So
So
does this mean, sir,
uh,
that
few comments.
the road width for the
Hmm?
cars does this mean that if we only use 2.5, that the excess of the road width will go into the lanes for the regular cars?
The road is
It will just make the car lanes uh it will make the car lanes
Wala kasi, sir.
wider. Okay.
Hello, since wala si sir, yung finals pala after midterms na lang sasabihin ko. Ayan na, wala, papasok na siya. Wait lang.
Kapag after midterms ba, mas mahirap?
Ito na. Diyan na to sige.
oh I don't know why I suddenly go out. Okay. Sorry. Were you able to get the last message? Yeah,
Sir, you were
two
quite a
points.
bit
No?
choppy. Yeah, you were quite a bit choppy earlier. So you're saying we just have to remove the all or nothing scenario because we do not have the audit data. Or
Yes. Unless you have the audit data, that's fine.
Okay, sir.
And yeah, can you enlarge a little bit the network? Because each intersection, you don't even have any alternative to go left or right. Like,
Okay. Maybe Andre can.
That's what we plan to do, sir, if by having more nodes in the CPD.
yeah, but that only for the bike. But how about the car that you include? You don't give any choice for the car to move.
Okay.
Sir, the IFN we plan to use is for the roads. So but bali, we use and we do two scenarios as mentioned, the without the bike lane and the one with the bike lane. But the flow would be for private vehicles. IFN to be used only for private vehicles. Then how do you say this?
What I mean is you need to include the surrounding area of the bike lane so that the car can have alternative choice to move different path, different way if they are not using that lane, right? Without giving them alternative to go, then basically you're modeling the traffic that is in the loop only.
Okay. So
Yes, sir.
we'll also include the lanes going inside the CBD.
Hmm.
Okay. That's a lot of lanes.
You can easily download using IFN transport, so you don't need to do manually.
Sir, I have a question. I got a little confused about the downloading of the notes in the website. That's why I opted to do it manually. I wasn't able to figure it out. Can I schedule a consultation with you, sir, on how to do it using the site?
Yeah, yeah.
Thank you, sir.
So later we will do that after
Thank you,
your
sir.
presentation. Okay. Right. So
Actually, sir, that's what stopped me from manually placing the nodes on the entire CPD because I didn't know I wasn't getting how to export, how to like to use the the web the web solver to get the
okay,
nodes.
okay. We can check later. Okay. Uh, who's next? Yeah. Thank you for this group.
Thank you, sir.
Yeah.
Sir, can we go next?
Yes. Go.
Sir, can you make me a co-host?
I think you are host already. No. In fact, I'm not the host. So who who whoever the host is,
Sir,
like
I made him
host.
co-host. I made him co-host.
Okay. Okay.
Thank you. Sir, can you see my screen now?
Yeah. Okay. Good.
Okay. Sir, good evening, and to my classmates, colleagues, good evening. So we are our group name is Cardis Beast. So composed of Bien Caluspusing and Katinga Katimpo and yours truly, Paulo Gutierrez. So our topic is the NLEX Harbor Link decongestion study. So for the brief introduction and background, so the NLEX, the North Luzon Expressway is the main gateway connecting Metro Manila to Central Luzon and the Northern Luzon. And then the Harbor Link is one of um the 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 access of Metro Manila to NLEX. Uh, it connects Metro Manila it connects the northern provinces to Valenzuela or Carohatan in the west side, and Quezon City or Mindanao in the east, and Caloocan, Balintawak in the south. So for our problem statement, just for context to everyone, a harbor link is an interchange. So it's composed of two levels. So our problem statement is the problem here is the merging of vehicles from the Karuhatan, yung from the west side going to the north. So the vehicles have to use the interchange. The you can follow the blue line, so they can use the interchange
Mhm.
and then use the loop going to the north, and it conflicts with the vehicles coming from the north and going to the east side to the Quezon City or the Mindanao area. So it conflicts, so you can follow the orange line. So it forms a weaving section on that red portion. So it is based on the studies, based on the review of RRL. It is one of the most complex uh, issues or problems in transportation. So this conflict creates a weaving section which reduces the capacity of the interchange and forms a queue of vehicles. Our objective is to reduce the conflict in the weaving section and eliminate the queue of vehicles on the weaving section, and of course on this whole interchange. So our hypothesis, by increasing the capacity of the weaving section, it will reduce, and in the cloverleaf ramps, it will reduce the conflict within the weaving section and allows the free flow of vehicles, thus eliminate the queue of vehicles. So for our methodology, here's our conceptual framework. So we have reviewed relevant traffic data and conduct traffic surveys, and then we analyze the interchange. We characterize it, identify the peak hour, and develop the flow and the OD trip matrix. Next procedure is we did it in the IFN model, input the road network characteristics, input the traffic data. Then next we assess the base scenario, which is the current scenario, the actual scenario that's happening right now. And then from that base scenario, we have results that we will use to identify the problems and formulate the alternative scenario. And then next is we have to assess that alternative scenario and then come up with the conclusion and recommendations. So for the initialization, the inputs to the IFN model. So during our modeling process, we have consulted with Prof. Cardi with this. So in the OpenStreetMap, there's a few missing links on this interchange. So using the QGIS, we have modeled, we have added the model, the missing links, the ramps are missing in this interchange in the OpenStreetMap. So we use the QGIS to add it, and then for the constraints or the the constraints we have used is the capacity. So for the main carriageway, so the main line of this expressway, we have used the 2,200 PCU per lane per hour, per hour per lane. And then for the ramps, since it is the main carriageway, the maximum limit is 100 kph, and on the ramp we have used the 850 PCU per hour per lane, because it has a much lower speed limit of 40 kph. So here are the screenshots of our inputs in the IFN model.
Very smooth.
So for the traffic data, so here is the figure of the OD matrix. So we have identified that the peak hour for this interchange is from the 10 a.m. and 10 a.m. to 11 a.m. and the majority of trips are of course the NLEX north to NLEX south, which is classified as the yellow arrows. And in terms of ramp volume, the high number of vehicles are using the southwest and the southeast cloverleaf loop ramp. So it is the 1,379 and the 1,069. That's where the weaving effect happens. So for our analysis of the base scenario, we have run the scenario with the inputs of the traffic flow with the OD, and the results is that the average congestion level is 112%. So this is just the average, but we have a maximum that reaches to 644%. And then for the network travel time, the maximum is we have a result that reaches 6,000, and the network delay that also reaches 6,000. That's counted for seconds. So in summary of the base scenario, in the figure, you can see that the red arrows are represented as the level of service F, and there are some that represented as level of service C and D. So the cloverleaf ramps links 8, 9, 10, 11, 12, 19, 21, and 28 as identified in the figure showed above 100% congestion and highest delays. And after this, we have identified here. Based on the results, the weaving section is evident on the link 5 and 17, which is identified dun sa the merging and diverging points of the interchange. And one of the issues that we have identified is because of the inconsistency of the lane configuration results to bottlenecks to other areas that plug the network. So there are lanes that coming from 3 lanes that then the following link is just 2 lanes, so there will be a bottleneck issues. So here is the summary of the issues. So in the figure, the blue dots are represented as the bottlenecks. So those are transition lanes from 3 lanes to 2 lanes or 2 lanes to 1 lanes, depending on the location. And then there is an evident issue of weaving on those red highlight proportions. So for the alternative scenario, I'll turn this over to Kat.
Hey, good evening. So, naka-next na ba? Pao? Wait, the slide is not yet in the alternative scenarios. For a while, Prof, will just repeat the screen share.
Hi, sir. I was Kat, can you share it?
Ben will share.
Okay.
There. So, the first alternative scenario is simply adding 1 lane to the cloverleaf loop. So, what we try to do is trying to make changes little by little just to for economic concerns. So firstly, the first alternative scenario will address the low capacity of the ramps that cause long queues and spillover. So next slide, please.
Next.
So there. The results of the alternative scenario 1. So originally, the base scenario, the congestion level is 112. So the congestion level was seen to decrease by 7%, but wi- this is still LOSF way above 100%. So with this, we needed to add additional countermeasures. So moving on to alternative scenario 2, there. So in addition to lane widening on the cloverleaf loops, we considered lane widening also for the right turning movements to and from the north lane, which is corresponding to links number 8 and 19 as in the figure. So this will address two things based on our hypothesis. Firstly, the low capacity of the ramps and the high traffic volume along these links as mentioned in the base scenario. Next, please. There. So based on the alternative scenario 2, the congestion level is now under 100% at 98%, but this is still equivalent to LOSF. So with this, the network travel time and network delays were also seen to decrease. So basically, there were some improvements in the network performance based on the first two scenarios. So next, please. So our third alternative scenario. So for now, these are the alternative scenarios we have considered initially, but of course, we are also considering after this. So in addition to the first two, the lane widening on the cloverleaf loops, lane widening on the right turning movements to and from the north leg. Now we added lane widening on the receiving links. So the links, as you can see in the middle of the intersection. So these are the links that receive the turning movements from the cloverleaf loops. So this will alleviate, ideally, the formation of bottlenecks due to the varying or inconsistent road width. So next, please. So for the last alternative scenario we have modeled so far, the congestion level was seen to further decrease from 98, now it's at 93%. So the changes we have made so far have caused a positive effect on the congestion level and network travel time and delay so far. However, the LOS is still on the extreme side. So for the conclusion, I will be turning over to my group mate Bien.
Hello, good evening. To summarize all the results from our IFN iterations, there have been slight improvements per scenario, around 5%. Uh, I will be sharing the visualization of the congestion levels exported from IFN to GIS. This is the base scenario. As you can see, there are a lot of links with LOSF or with volume over capacity ratio exceeding 100%, exceeding or equal to 100%. For the alternative scenario 1, we could notice the improvement for links 19, 28, and 29 from D to C. However, due to this, the weaving section of link 5 became LOSF. For the second alternative, due to the improvements to the further improvements, the weaving section of link 5 is no longer LOSF. And finally, for alternative 3, same LOS in general, but the congestion was decreased by 5% due to the improvement to the receiving lanes. Sorry. For the conclusion, we came up with the following: that more drastic traffic management measures need to be considered, such as but not limited to the following. We are planning to present one of these in our final presentation in order to attain our goal of achieving LOSC or around 60% congestion. And that lane or road widening should consider all adjacent links, not only the congested links, in order to prevent bottlenecks caused by the varying road width. Thank you for listening.
Yeah. Okay. Very, very nice. So is there any comment or question to this group? Anyone? I have only one question. Okay. I think your presentation is very nice. Okay. Is there any cloud node that you presented there, because your network is actually not strongly connected?
Yes, Prof, we clicked on the cloud symbol in the IFN model to generate cloud nodes and links.
Okay. Okay, good. Yeah, thank you. You can proceed with the almost final, right? And the paper. In fact, you can actually publish this work. Yeah, very
Okay,
good.
Prof.
Right.
Thank
So is there
you.
any? Yeah, thank you. So next group, who will present? Yes, Jovi. Yeah. this is similar to earlier bike lane. So this is bus lane and motorcycle lane.
Hello, sir.
Yes.
Hello, classmates. Good evening. So, me and my group mates are going to present the scenario analysis of increasing the number of bus lane and adding motorcycle lane on the traffic flow along EDSA. Next slide. So, for our outline, we have the background, the objectives of the study, our methodology for this study, and we will also going to discuss our initial result and ways forward. So for the brief introduction, we all know that EDSA is the major connector between the northern and southern parts of the metropolitan area as well as the south and north Luzon in general. It runs around 24 kilometers from Caloocan in the northern part of metropolitan area and to Pasay in the south. For the next slide, for the current EDSA traffic situation, based on the latest report from MMDA, the annual average daily traffic in EDSA already reached 410,844 vehicles in 2022. And the average speed during GCQ period is at 27.6 kilometers per hour only for northbound and 31.57 kph for southbound. Due to this traffic situation, various initiatives have been implemented, such as the EDSA carousel of Department of Transportation. Next slide, please. So for our research, our study aims to investigate the effectiveness of increasing the number of dedicated bus lanes and adding motorcycle lanes along EDSA and minimizing traffic congestion. Basically, our research question is, how will these scenarios impact and reduce traffic congestion along EDSA? And our objectives of this research is first is to assess the impact of increasing the dedicated bus lane on travel time, congestion, and traffic density along EDSA. And then assess the influence of adding motorcycle lane. And after that, we are going to compare and rank the scenarios, including the existing base scenario, in order to identify the most feasible traffic simulation for implementation along EDSA. For the next part, Mr. Jovi will discuss.
Hello, good evening. So for the data collection, so this is for the methodology. So first for the data collection, we collected comprehensive data on the current state of EDSA, including traffic volumes, vehicle types, roadways, and other relevant data. And then we processed the data through modal split analysis. So first, we processed first the data for the base scenario, and then we're gonna look at it first, and then we'll compare it with the alternative scenario. We're gonna plug in the values for the alternative scenario, and then we'll identify which one is the best among the three, and then we'll try to simulate them through IFN, and then analyze results and provide recommendations. So for the data collection part, so the annual average daily traffic for EDSA was collected from the MMDA online, and then we try to convert the PCU for each vehicle volumes through the passenger car equivalent factor, and then we sum everything, and then we got these values. So yeah, and then we try to project the values from 2023 to 2033. So yeah, and then we used a growth rate model instead of the linear regression model, because when we're using the linear regression model, we get decreasing values, which is counterintuitive, provided the increasing annual average daily traffic of EDSA. And then for the demand per lane, we computed it by dividing this demand by 24 and then the number of lanes. So we assume that the number of lanes for the whole length of EDSA to be 10, and then yeah. So from there we got these values, and then here are our assumptions. So other than the first two items that I've mentioned already, we assume that the capacity to be 1,250 for each lane. So we got that from the capacity of the EDSA, which is 300,000. So we divided 300,000 by 24 and then by the number of lanes. So we got this value. And then we assume the car occupancy to be 3 persons per unit, which we got from this research, which can be accessed through this link attached here. And then we assumed max speed to be 60, which was declared by the MMDA, and the PCU conversion for bus to 3.3, and bus occupancy to 34, which is the average bus occupancy based on the JICA report that can be accessed through this link. And then the total length of the EDSA to be 23.8, and we assumed values for alpha and beta to be 3 and 4 respectively. So from those values, we got this result for the base scenario. So dividing the demand and the capacity, we got 1.008 and then so on. And then the travel time, we used the PPR formula since our congestion level is more than 1. And then we got these values, and then for the density, yeah, we divided the demand by the total length of the EDSA. So that is the base scenario, and ways forward, we are in the acknowledgement that we still have to polish the base scenario model. And of course, inputs and recommendations from the class is very much welcome. And after which we would run the alternative scenarios, adding additional bus lanes and adding a dedicated motorcycle lane. And third, we would analyze the results and evaluate the scenarios. And lastly, we would provide recommendations based on the studied scenarios that will minimize the traffic congestion along EDSA. That's all for our group. Thank you.
Okay. Is there any question, comments to this group? Yes, Marie.
Ano, because when we started, I'm not sure about EDSA because I have not been in Manila for quite a while now. But but as far as the data I saw online was, I assume that there is bicycle lane in EDSA. So maybe if you mentioned to us, Andre, you told Andre and I that it's not advisable to have a bicycle lane in EDSA, then maybe it will help their group in their analysis if they can add it that it's not recommended, and maybe they can use the bike lane for their motorcycle lane, the existing bike lane in EDSA. That's answer.
Any comment for the group? Yeah, okay. So several things I would like to comment it. Okay. You mentioned the traffic is 410K, right? 400,000 AADT, okay, annual average daily traffic. That means per hour in the peak hour, usually about 10%. You don't divide by 24, but divide by 10 only. Because if you divide by 24, that is not the peak hour. Yeah. So approximately between 10 to 12% rather than divide by 24. Number two, your capacity is also very low. If the lane is about 3 meter and 3.5 meter, so usually around 1,800 to 2,000. But your capacity is only 1,250, right? So this is a bit low. Okay. And then you probably want to analyze, is there any bottleneck of the capacity along the ETSA? That probably the cause of the congestion rather than the putting it into the bike lane or the bus lane itself. Yeah. So instead of increasing the lane for the bus, for example, you can actually improve the capacity for the bus itself. That's another alternative, right? And then bicycle lane, I don't know why you want to have a bicycle lane in ETSA. Okay, bicycle is supposed to be for feeder service rather than for the main hall, right? So it's a little bit strange concept if you want to do a bike lane on the main road in the highway rather than to serve as feeder service. When you use bike, you're supposed to use from the house to the main station rather than from the house to the actual office. That's the concept that I'm not sure need to be introduced there or not in along ETSA. Okay, so is there any other comment or question to this group, probably from other group? Yeah, your analysis also, the last group, yeah, the analysis is not yet finished. So what is the alternative scenario, and does it actually make it better or not? Any comment, Jofi?
Sir, I think I missed you, sir. So can you repeat it, sir? I didn't hear you clearly on my answer. Can you repeat it? If
Okay.
it's
So first, okay. First, the peak hour, okay, peak hour traffic volume is usually about 10% of daily volume, not divided by 24. Okay. Number two, your capacity is very low, 1,250 compared to the capacity in the highway capacity manual, usually around 1,800. Okay. And number three, okay, you need to consider the bottleneck in the capacity along ETSA. Okay, so this is probably something that you need to consider. And number four, instead of adding bus lane, okay, probably you want to increase the capacity per bus. Okay, larger bus or double deck bus. Okay, that probably also another alternative solution. And then the same number of lanes Okay, you want to reduce it further for motorcycle. So I'm not sure, okay, is that a wise decision or not, but you can analyze, no problem. Can you hear?
Yes, sir. Thank you, sir.
Yes.
Sir, question. Regarding,
Okay.
sir, your third comment, sir, to consider the bottleneck along EDSA. Can
Mhm.
we analyze, sir, specific intersection, for example, EDSA or Tigas intersections, sir,
That's fine.
for our study? Just one intersection.
But that will be a different topic from what you are doing, isn't it?
Mm. Okay, sir.
So anyway, you can actually get the data easily from the map. No? You can download that and then check the capacity. Is there any bottleneck on that or not?
Okay, sir. Okay.
You probably need to do it several times, section by section rather than, because it's 23 kilometers. I guess you cannot download at once. Okay. Who want to present next? Other group.
Oh, sir, I think we're the last one.
Only 3 groups?
4 groups, sir. 4 groups, sir.
Ah,
I think
4 groups, sir.
okay, thank you then. Okay. Yeah, Abby, you want to share something? There, you still have one.
Hello. Hello.
Yes.
Sir, I'll be presenting our project.
Mhm.
It is a comprehensive analysis and proposal for the traffic management in Pilar Bataan. And my group mates are Daisy and Abby. And next slide, please. So the content of our report is the introduction, current road networks and traffic condition, base scenario and alternate scenario. Next part, let me introduce the study area or the specific the municipality of Pilar Bataan, which is a third-class municipality. One of the oldest town of Bataan, it is located in the southeast portion of the province of Bataan. It is bounded by municipality of Orion in the south and the city of Balanga in the north, and the municipality of Bagak in the west, and the Manila Bay in the east part. So it has a total land area of 4,520.20 hectares. So with a total population of 46,239 as of the 2020 PSA census. Next, so the current road networks and traffic condition. The existing road infrastructure. Under Pilar's jurisdiction, there are 2 secondary roads and 2 tertiary roads. The 2 secondary roads are those supplementing the main road or the National Highway, a Roman Expressway, and the part of the J.J. Lina Road. Total road length for the secondary road is 11,241 kilometers. And the 2 tertiary roads, or those that serve to move traffic away from the narrow or the quieter streets, are the junction of Alayak, Balanga, Maribel Sport Road, and part of the Governor J.J. Lino Road. The total road length for the tertiary road is about 5,943 kilometers. Next slide, please. So this is the map of our Pilar Road network. On the right side is came from the municipality of Pilar, while on the right side is the more clarified map that we generate. So on the left side, we could clearly see the map of the municipality and the divisions of the barangays and the major roads traversing the municipality. The one that has the blue line is the junction Layak Balanga Maribel Sport Road, and the one with the orange line is the Governor JJ Lino Road, which is also known as Bataan National Road, and the junction Layak Balanga Maribel Sport Road is also known as a Bataan National Road, while the red one is the Roman Expressway or our Bataan Provincial Highway. So, next slide, please. So the public transportation routes and operators. There are two main roads traversing the town, both passing through the town, catering commuters from Limay Maribeles, the Super Roman Highway, and Bagak Morong or the JJ Lino Road, and vice versa, and caters most of which are workers, employees, and colleagues and students. The Super Roman Highway caters to big buses such as Bataan Transit, Genesis, servicing passenger coming from the town of Bataan, going to Manila, minibuses, and vice versa. The public utility jeepneys or the PUJs flying from the Balanga to Orion Limay and vice versa use the national road. Also, the PUJs and the minibuses fly from Balanga to Bagak Morong and vice versa use the JJ Lino Road. And the presence of Colorum Tricycle also use the national road to cater passengers within the town, point to point. Next slide, please. So these are the pictures of the what is the current a mode of transportation in the municipality of Pilar Bataan. So next slide. Abby.
For our study area, the group opted to choose the Pilar Central Business District, which is connected to the mixed-use character of its neighboring city of Balanga. So here's the Central Business District of Pilar, which is connected to the city of Balanga and Orion. So to give a quick background, Pilar City CBD is connected to the mixed-use character in the neighboring city of Balanga. It was purposely put there to facilitate a seamless effort in catering to an overflow of urban sprawl coming from Balanga, which is the center of the Bataan province. The commercial spaces demanded by urbanizations of Metro Balanga dictates of the succeeding LGUs connected to the Bataan National Road. This one, Bataan National Road, and along the Bataan National Road, where you can see the municipal hall, the schools, the other commercial establishments. Having that said, the CBD has attracted many public and private vehicles traversing on the area, specifically on this area. This is the CBD of Pilar. The municipality. Can you see my pointer?
Yes.
The municipal hall is located here, and the schools and other commercial establishments, wherein it is coming from Balanga, going traversing along Pilar, going to other municipalities of Bataan. This is the national road, Layak Balanga and Balanga Marivela Sport Road, or the Bataan National Road. And this is the Governor JJ Lino Road, while the Roman Expressway. This is the Roman Expressway. For JCT Layak Balanga Marivela Sport Road, the provincial buses are not allowed to enter here. Also this one in JJ Lino Road. That's why coming from Balanga and other cities, only jeepneys, private cars, tricycles are only the ones who can pass through here. While for the Roman Expressway, here's the provincial buses traverses here, this area. But in this JCT Layak Balanga Marivela Sport Road, many people were coming in and from, especially during rush hours, because of the because of the activities going in this area. That's why during rush hour, it has a very congested area. So we we opted to use these nodes as our references in checking if what is the scenario on that specific area and what would be our alternate scenario if ever we come up with a solution on regarding on the regarding on the problem of their regarding on the traffic condition in the area. For the base scenario, Resi will present.
I'll just share my screen.
Hmm.
I'll let me know if you're able to see my screen now.
Not yet.
That's it. So um, it's-
Okay, 10%.
is it already presented this?
I haven't seen yet, but you can present, no problem.
Wait, so I'll just reshare it because it's not. Yeah,
Yes. Okay.
Are you able to see my screen?
Yes. Yes.
So we actually got the notes from the road traffic information application RTA by our department, Department of Public Works and Highways. So it's loading. You can actually access some of the basic info that you needed here from like basic traffic information. So kilometer posts, AADT, traffic survey sites, and others, even the number of lanes and volume capacity ratio.
Okay.
So from there, we got like what Abby said, we got 6 nodes. We named it A, B, C, D, E, and F around the municipal center of Pilar, and also including the national road here, which is the Roman Expressway. And then we got the AADT from the Department of Public Works again. We got the 2017 to 2021 AADT with 13 types of vehicle. I mean 12 types, but we reduced down. Then we project it from site A to site F. We projected it for the 2023 AADT using forecast linear or regression. So we got the 2023 values for our AADT. And then just to present our base references, we have used this BHCC, or the basic early car capacity, or the link capacity. For the rural and urban, we have this reference from the department order of our department. And then also the level of service. Here is the level of service and also the description for its traffic condition. And then also, wait, I'll just move it here. For the, just a reference for the PCEF, or the passenger car equivalent factor. We also have that one. And also, I heard earlier, sir, that the peak hour factor is actually 10%. Okay. But yes. In our agency we use 8, so I think it's better.
Okay, 8 is acceptable.
8 is also reasonable. So.
Yes, divided by 24 is not.
Yes, sir. Divided by 24 is not really a good approach. So from there we got the from 2 we have identified 18 links from that from this scenario. So we have this 18 links, and I actually labeled it as like A going to the left, A going through, something like that. Just for me to familiarize the directions of the scenario. And then we reduce it to only 5 types of vehicles because it's too much.
Mhm.
We consolidated the trucks and also the small bus and the large buses.
Okay.
We considered it just one. And then yeah, we got it here. We got the ADT and multiplied by 8% just to get the
Mhm.
hourly, so we could actually come up with our VCR or and LOS given not it's already formulated, sir, that we
Right.
have.
Right.
So whenever we change anything, the VHCC will change, VCR will change, LOS will also change. What based on our input here. So that's
Yeah.
a model that we use. And since actually it's kind of frustrating that most of the links are LOSA and only A to B, this one, A going to B or the A going left. I mean A going to the right pala. So that's it. It's only that one. Given that only jeepneys and tricycles are passing that road network or road section, I mean. And then we actually did a classic transport demand analysis given the
Right.
trips
The whole
proposed and
thing.
trips attracted. I mean yeah. And then we have used the assumptions. Yeah, this isn't where I'm not sure at the PCU conversion of the bus and GIF, but we can also use the PCU conversion here.
Right.
GIF is 1.5 and bus is actually 2, but based on the examples we use in the assignment, we used
Usually 3.
actually 3. Yeah.
But
And
anyway,
then
you can get from the literature.
yeah. So base here, it's all also formulated whenever we change anything from the basic inputs here, from the base traffic, everything will change here also. So this is the base case. This is the travel time and congestion as well. This is the
Mhm.
congestion.
Hello.
Yeah, this is the only one that with the almost 0.40 congestion or 42% of the capacity is being used. That's the only problem that we have identified here. This one. This is actually 6 lanes. And some of the parts here are 4 lanes. But minimal just a portion lang. And then we and actually I'm trying to configure if that based on the links I mean if percentage bus will be used for every link, what will be the change in the travel time? So there is also a minimal change in the seconds. Only 0.seconds will be changed in the travel time per minute here. So that's actually where we end at our analysis. And we are Abby has a query about IFN also. And we also wanted to ask or consult with what we are going to do with this scenario. That's
So
it.
no alternative scenario yet.
We wanted to add lane only in A to B. So that will just double the capacity here. So if we wanted to just reduce this one, and also how we can actually sustain having the same LOS in the near future, or maybe we can project up to 20 years.
Okay. Okay. Before I make a comment, is there any other groups want to give comment or question to this group? Okay, I would like to ask, what's the difference between congestion and your VCR? Isn't that the
It's
same?
Actually, it should be the same, sir. I don't know what.
Yeah, your PCR here is like 85%, but
Yeah,
your congestion is only 40%. What's going on?
yeah, right here, sir. Uh, Given the assumption that all the road users are in terms of car, I guess.
I mean, why there is a 0.8 while ago, which is congested, right? And 0.4 is practically no traffic at all here.
Uh, yes, sir. This is
This
the
level,
scenario. I
yes.
think this is the scenario, sir, where all the users are car users or 580.
Okay.
If every link will be a car centric.
How many percent is this? The first one is 42. The congestion is 42%.
Yes, sir.
Wow. With on oh, no. I want to ask, what is the meaning of this one? Sorry.
What, sir? This one?
Yes. No. This one. The congestion 42%. What
Uh,
scenario is this? Yes.
what scenario?
Yes.
I think this is the basic scenario, sir, that all users are that all the users of the road network is in car.
Oh, without public transport, it's only 42%, the congestion. No congestion at all. There's no
I think
problem.
so. Yeah, sir. That's actually our problem. There is no problem with the area. That's why we actually tried to um transpose it to the network representation, and we found out, I guess, that the network is underutilized. It's actually
Right. So probably your demand is too low, or your
yeah,
OD matrix
utilized,
is too
yeah.
low.
Yes. That's why we actually need your advice if we're going to push through with the area, or are we allowed to
No, in reality, that is heavy or not?
what do you mean heavy, sir?
Yeah,
Heavy
I
to
mean,
change
yeah, I never been to this area, so you tell me what is the actual situation there.
actually, sir, there's a current traffic or congestion here in Alauli just because of the construction of a flyover here
Okay.
in this intersection. This is a national road. I think the Alauli is around here. Am I correct, Marie?
Yes, yes.
Yes. So that's the only congestion happening right now because of the construction. But I think the construction is about to finish this year. Tama ba? Am I correct?
Yes.
This year also.
This month.
But that's the only one.
Okay, so in that case, it is more interesting if you want to simulate what is the effect of that construction, for example. Is that something that you want, or?
From the construction from the past years to now, up to the
Current situation is during the construction, and then after the construction finish, what will happen? Something like that.
okay, sir. Well, like projection of what will happen if the flyover is already constructed.
Yes, because you don't
What?
have the data before the construction, right?
Yeah, yeah. What do you mean, sir? We don't have the data before the construction.
No, if you have the data before the construction, then you can simulate three scenario: before the construction, during the construction and after the construction.
Ah, okay, sir. So it's just the impact of the construction of a flyover in a
Right.
national road.
And you want to know what is the impact of that construction. Of course, temporary, but at the same time, what is the actual impact, right? That would be nice to see.
Yes, sir. Can we also include what are the traffic management plan they have
Yeah, yes,
set
of course.
during before, during, and after? Since
Right.
what are the things that they the implementer or the implementing office is doing, if what are the improvements that they need to do to the traffic management whenever there is a construction of a
Mhm.
road or
Yeah, you can include that. Yeah. Right. So thank you. I think the problem here is I don't know what is the problem. Right.
flyover. Hello.
Sir,
Sir.
if ever we have to change the study area, um, I think we can do it fast, Resi, because the
So
formula for
you
the
you've
computation
done a lot
is
already. So it's you have done a lot already in here. So probably you can stick here, but improve the
Yes.
you know.
okay.
I guess this
Yes,
is the actual problem is here. Your OD matrix is too small.
yes, sir.
Right. So in that case,
Yes, yes, sir.
if instead of using this OD matrix, if you use IFN, for example, you probably can use, for example, based on maximum congestion, or you can include this OD matrix into the IFN. That will be helpful also. So
Yes, sir. Okay.
mm,
Abby, do you have do you have any questions for sir for the IFN? I
Yes,
think
sir.
we have a query.
Because do we still have time? But sir, can we just have a schedule meeting
yeah,
regarding the
you can email me.
already
Yeah.
input data in the IFN, but I don't know if it's correct. But it and in at the base scenario for my IFN, when using this data, it gives us I think 70% congestion. So I don't know if it's correct or not. So we can just meet na lang. I can just meet
Okay.
some other time
Yeah,
for
sure.
this weekend.
No problem. Yes.
Okay. Thank you.
Let's schedule it.
Yes.
Right. So thank you.
Thank you, sir.
Okay. So I want to discuss with you. So from now on, I will put this video into public. Okay. So if you don't like it, so you can close your camera. Okay. Thank you. Let's discuss today about the random walk first. Yeah. Or probably we discuss first about the IFN workshop so that you will have some idea. Okay, so wait a minute, put the screen. Can you see my screen?
Yes, bro.
Okay, so here, you can download this IFN Excel add-ins. Okay, and if you want to use the online IFN, you can read the user manual here. Okay, so if you download this, okay, so I have downloaded this one earlier. You will have an add-ins for Excel. So here is the one that I downloaded. Okay, and this is the add-ins for ideal flow network, and this is okay, and this is the manual of that add-ins. Okay, so this is how you install. Okay, you just double click the ideal flow XLAM. You can do it now if you want. Okay, or if you can also put this file into this folder. Yeah, this is inside your own computer. And then you can open the Microsoft Excel and then enable the macro when you are prompted. Okay, then you're supposed to have it. Okay, now I will show you in a moment. So this is my Excel. Okay, I have a empty book one here, and then you go to option, okay, add-ins, okay, and then go, okay, there. If you have that Excel add-ins inside your file, you're supposed to have these links here, okay, or else you can browse, okay, and then you can click on the ideal flow, okay, and then check this one, and then click OK. Now, if you can do that, okay, then whenever you put here equal n underscore, okay, you will have all the menu of IFN add-ins. Can you see this? You can try on your own also. Okay, so for example, I will create here random RMD, random capacity matrix. Okay, so here, so say example, you want to create a capacity matrix. How many nodes do you want? For example, A, B, C, D, E. Yeah, let's do 5 nodes. Okay, so here is also A, B, C, D, and E. Okay, so and this represent the number of lanes in your simple network. So I put it into a yellow like this. So what happened is I click here, okay, and then you press together, okay, Shift, Control, and Enter. There, you get the capacity matrix, okay, which is random. Okay, you want to try it first before we continue further? For example, I can make it 2 to make it nicer. So this is the capacity matrix. See, okay, this represents the number of lanes inside your network. Okay, this is example how to use in Excel. So I copy this. This is the node, right? Say I have X and Y here. Okay, so let's put any number. Say I put 100, 100, 150. Okay, I will just add with this one with plus 50. And probably this is 100 again. Okay, so we just put any number 125, okay, 50, 300, and say 245. Okay, whatever name that you want to put here. And then you can write here equal n, okay, and then draw the network. Okay, so you have this capacity and then this node. Okay, there you get the network. Okay, now you can change this. Okay, say you don't like this in 100, so you can make it 150, something. There, you can say this one B is here. I want to make it the same, right? B is in the same. So, but the Y is, for example, 200. There, A is here. C. So where do you want to put the C? C is going to be 150, but here say for example you get 300 and so on. So you can set up your own coordinate, okay, to draw this network. Okay, so if I do, okay, now if you don't like the drawing, so you can also do like a copy here, back here. Okay. From here you can create what is called stochastic matrix. Okay. Basically, it's the same as you take the sum here. Okay, I put sum of this one. Okay, and then the stochastic matrix is basically just each of the lane, okay, divided by the sum on each row. Okay, so here is this value divided by that sum. Okay, so the J I will put value like this, then copy, I got this value. And of course, because this is random capacity, you can keep making different values. Okay, simply by press F9, recalculate to create new matrix, stochastic matrix. Because this is stochastic, the meaning of stochastic means the sum of each row is equal to 1. Okay, you can see that. Okay, so if you don't want to compute manually like that, you can also do it this way. So this is the S. So N underscore capacity to stochastics. Okay, so this is the capacity value, and you press OK. And then what you will do is you set the same size, okay, and then click here and then Shift Control Enter. Then you will get exactly the same value. Okay. Now from there you can calculate the flow matrix. Okay. Again, you have the same node. Okay. You have the same node here, right? And here you can put N underscore. Okay. So for example, you want to do from capacity to ideal flow. Okay. So to get this, you put into here. Okay. So, and then the total flow is equal 1. Again, you select the same size as the capacity matrix, and then you check here and then Shift Control Enter. You'll get the ideal flow matrix. Now, if you want to get the total flow differently, okay, say for example, I want to make it 100. Okay, so we can change that, right? So the total flow now here. Okay. I copy this first because if you run this, it will say cannot change the part of array. So I delete this all and start again. The one that I copy, you see, this is based on the capacity matrix and the total flow. And when you press Shift Control Enter, you will get the flow matrix. And to check, okay, the correctness of this, you can take the sum, okay, of the flow matrix, okay, and then you can also take the sum here. Okay, the sum here, the top, and then the sum of everything, right? So I will put here sum of all the flow, which is exactly the same as the total flow here. Right. And you can see the flow matrix here, okay, is pre-magic. What's the meaning of pre-magic? Okay. You look at the sum here, the sum of each row is exactly the same as the sum of each column. See, 9, 26, 8, 27, and 26. You will see here also exactly the same. Yeah. Now from here, you can calculate the congestion matrix. Again, I copy here. Okay. Okay. So to get the actual congestion, okay, you need to tell what is the actual capacity. Yeah. So say one lane, okay, one lane is equal to how many PCU? For example, 1,500, yeah, PCU per lane per hour, right? So this is the multiplier that we set. Okay. Then now you need to calculate the new capacity matrix, okay, in PCU per hour. So I will just copy this. It is 1,500 multiplied by this one, right? The capacity matrix. So then you copy to all. Oh, wait. This one is supposed to be with double. Right. Then you copy all to 3, 4, 5. There. Is that correct? So if you have 10 lane, that's supposed to be 1,500, 15,000. Now you divide your flow. Okay, you divide your flow with the capacity. Okay, that's it. And then you, of course, if error, that should be 0, isn't it? There. Now, this is the congestion level. Okay. So in that case, you can put the color code. Okay. Of course, this congestion level is very low because your total flow is very small. Okay. What happened is now you can calibrate, okay, easily. Okay. Say I want to get, okay, I want to get so that the congestion level is 0.9. Okay. What I will do is, see, this is what I will put as yellow. Yeah. I need to change the total flow, okay, so that the congestion level, maximum congestion level, so I will put here max congestion. Okay, so max congestion is the maximum, right, of this matrix. Okay, so this is very low. Okay, I want to get the total flow, okay, in order to make this congestion level become 0.9. So you go to what if analysis goal-seek, right? So I want to get this congestion level should be 0.9 by changing the total flow. Okay, it will run. Oh, did not get the actual result. We can continue. Okay, so it's set 0.9, 0.9 by changing this total flow. Oh, it's closer. So actually you can do it manually also if you want. So for example, 25,000, what will happen? Oh, it's too much, right? So 20,000. Still too much, 19,000. Okay. So it put 19,500. 19,000, probably 700. Oh, okay, it's close. Then when it's already close, you can put the goal seek. Yeah. This goal seek should be 0.9 exact. And then by changing this one, there exact now. Okay, this is how you calibrate the IFN. Okay, by calibrating the total flow. This is what is inside that IFN transport program. Okay, is there any question up to here? No question at all? So originally, okay, so you can go here at in the screen. Originally, the ideal flow network come from random walk. Okay, so you can actually get the flow matrix based on the number of trajectory that pass through certain links, right? So for example, when you pass your vehicle pass through certain links, okay, you count that as the number of trajectories, and then if you count aggregate all the trajectory that pass through the same link, this is called flow matrix. Yeah? Now, a while ago, I just demonstrate okay, that if you get the capacity or the flow divided by the sum of the flow, you will get what is called stochastic matrix. Okay. Now, the basic idea is simple. Okay. Assuming that you know, okay, the outflow probability distribution, okay, in each intersection, then you can generate a random walk on network. Okay, say I have this kind of network example. Okay, in each node, okay, with certain probability that you are given based on that stochastic matrix. Okay, you do a random walk. Okay, so and then you record this link flow as the sum of trajectory. Okay, and then the agent will keep moving until the time is infinity. Okay, so in this simplified version, I will just use a simple network with only 5 nodes. Okay, the edge length is 1, the agent speed is 1. Okay, so that means that each agent will jump from one node to the next node in one time step. Okay, and let's do it in the lab. Go to this lab, random walk on network. Okay, so in this lab, you can see the lab tool down here. You can generate a random network. Okay, in here I generated 5 nodes network, and then from this random network we generate random trajectory. So right, and then you can apply this trajectory to the network. Okay, and then you can run. You can repeat this generation, okay, to create a random walk. you see, every time I press here, I add 100 random walk, okay, and the result of the matrix is actually increasing over time. Can you see? Okay. So this is not random walk itself on itself is not so useful. Okay, but something going on here that once you increase the number of random walker, you see the sum here is almost the same. Right? Okay, the sum is almost the same. So if you get the relative flow based on the either total or standard deviation or any statistic here, okay, then you will see the total is approaching certain probability distribution, and they are approaching Prima-Chick properties. Yeah, the sum of each row is exactly almost exactly the same as the sum of each column. Okay, so this is the ideal flow. Okay? This relative flow is actually the ideal flow. Okay, because it's relative, so you can easily multiply by the GCD of the denominator of here. So if you put this into fraction, then you will put this into integer. Okay. So the simulation result, okay, if you just do a random walk, is practically useless because the flow will increase over time, okay, up to infinity. But when you actually, yeah, this is the example of the flow that increasing over time. But when you divide that flow with the statistic of the flow, so it becomes relative flow, okay, suddenly, okay, you will see become integer numbers. And not only the integer number, you can see the sum of each row is exactly the same as the sum of each column. So this phenomena, okay, is interesting. So this is what we call as ideal flow network. I hope you understand the definition. Yeah. So this is the another example. So we have 200 agent with 1,000 time steps. Okay. When you do it in Excel, you can do. And when you see, I divide by the total flow. Okay. The value is not exact, but you will see there are certain value that almost the same. Yeah? For example, here 8 and 8. Yeah? This one is 4.3 and 4.3 and so on. And when I divide all of this, instead of divide by total flow, I divide by the minimum relative flow, I will get almost integer number. Okay. So if you check the relative node distribution, okay, this is actually the integer number based on each node. Okay. So this interesting phenomena, okay, because now regardless the number of agent that you put or the simulation time, okay, when this number is very large, okay, you will have eventually an asymptotic value, okay, in the long run of the relative flow, okay, that is integer number, okay. So and that asymptotic flow ratio is actually a good indicator of the importance of the links itself, right? And one nice thing about it is actually based on network structure. So you don't really need to have the network utilization inside. So it is inherent properties of the graph structure itself, right? So, and the node will preserve the flow. Yeah? The total inflow will be exactly equal to the total outflow, right? That node preservation is what we call as Prima-Chick. Yeah? That means the sum of row is equal to the sum of columns. Okay. So you can try this practice. Okay. Say you have this simple network of 4 nodes A, B, C, D. Okay, and these are the trajectories that is given. Again, this trajectory actually random. Okay, and the first trajectory is ABC, right? Then you can put ABC into flow. So that means A to B and then B to C. Okay. So in that case, you see A to B is 1, B to C is 1. That the flow matrix will become like this, right? And check the stochastic matrix. Okay, this one divided by 1, so you get this one. Okay. Now, the second trajectory is BCT. Okay, so you can apply that. So we have BC and then CT. Okay. That means you need additional flow again in here. So earlier this one is already 1. This one is another 1. So then you can see PC and then CT. So now you updated the flow matrix. Okay. Repeating this, okay, for all the trajectories. So here, for example, C, B, C, A. So again, you parse each of this link, and then you put that into the flow. Then you will update the flow matrix. Yeah? And again, you update the stochastic matrix of that. Okay, this is how you do the random walk. Yeah? Again, you have the trajectory, and then you updated the flow matrix and the stochastic matrix. Yeah? Yeah, eventually you will get this value. Okay. Okay. At this point, you will see that the matrix, the flow matrix is actually not pre-magic yet. Yeah, this is because we have only a few trajectory. Yeah? If you have several thousand or 10,000 trajectories, then this is approaching, yeah, asymptotic to the ideal flow. So I hope you understand the meaning of ideal flow, okay, which is the asymptotic value of relative flow, yeah, that come from random walk. Okay, now if you do random walk like that, that will be very complex, right? Every time you need to simulate, and if you have a very large city, how can we get that value of the flow? Okay. So one way to solve that problem, yeah, is okay. Let's do it manually. Let's do the IFN computing IFN manually. Can go to the next slide. Can you see? Yeah. In this lesson, you will learn how to compute IFN manually using paper, pen, and calculator. Okay. So again, what is IFN? I concluded that IFN is just the steady state of the relative flow distribution, okay, in a strongly connected network where the flow are conserved. So these are the simple jargon. Okay, IFN basically irreducible. Irreducible means strongly connected network. Pre-magic, that means the flow are conserved. What is the value? The value is come from the Markov equilibrium. It is the asymptotic value. Okay, this can be represented as either network or matrix. Yeah, and you can check on your own. Okay, they are the code is freely available in GitHub. Okay, the IFN transport itself is also in GitHub, and also have the in Excel and the online version you already use in Revolut. So why we use IFN? Yeah? IFN is basically a modeling metaphor, okay, and naming convention, okay, so that we can actually use IFN for other modeling purpose, not only for transportation, right? So as long as your problem at hand can be formulated as flow equilibrium, in a strongly connected network graph, then you can use IFN as your modeling tool. Right. So these are the advantages of using IFN. Okay, you will get directly the steady state solution, which is the long-term stable equilibrium. Okay, and the actual formulation is come from maximum entropy principle, and the flow are conserved, and you get directly from the network structure. Okay, so that means the number of data that you need is actually very minimum. It is only the network. Okay. Now, it's not panacea, so that means you cannot use IFN, okay, if one of these four assumptions are not satisfied. Yeah. So first, the network must be strongly connected. It's a closed system. Second, the flow must be conserved. There is some balance. And then there is some kind of probability or stochastic local information on it. And then we are dealing with long-term equilibrium, not day-to-day operation. Yeah, in 1 hour, what is the actual next value? We don't know. Okay. We are talking about the long-term solution, right? And because of that, okay, because we have a ideal flow as relative flow, then we can scale up or down to produce what is called equivalent IFN. Yeah, the one that I demonstrated a while ago in the matrix in Excel. You can actually scale up and down the flow, okay, so that you can get the equivalent IFN. Okay, so let's do that computation manually. Okay, say you can create a small network on your own, okay, on paper. Okay, and then you can set any origin node, okay, and then you can set any amount of flow into that origin node. And then if a node have only one in link and one out link, okay, the same amount of flow continue from in link to out link. Yeah. If the node have more than one in link, okay, the sum of all flow, okay, from in link to the node, okay, and then when the node have more than one out links, yeah, distribute that inflow, okay, based on the probability distribution. Okay, okay. If you have this kind of very simple triangle, what will be the ideal flow matrix? Yeah, yeah, because you have only one outlink in every node, and the ideal flow matrix will be 1, 1, 1. Okay, this happened with your project a while ago for the bike. Okay? You have only one loop, so basically your flow is exactly the same. That's why I asked you to expand the network. Okay. So how about this one? Yeah. What is the basis ideal flow in this network? Again, you will get exactly 1, 1, and 1, yeah, because you have only one outlink. Okay. Okay. In this example, okay, I want to apply the simple idea of equal probability, okay, so that you can compute manually, okay, without much thinking. Yeah. So say I apply a flow of 100 here in link 5 to 1. Okay. And then in node 1, you have two links, out links, right? So because we have equal probability, what you will do, you divide this 100 into 50 and 50. Okay. And then here in node 2, you have 50 coming in. Now you have equal probability. Then what you will do, you make it 25, 25, right? In here now you have in node 3, Okay, so in link, yeah, the flow is 25. Okay, you have two out links. That means you divide by 2, okay, 12.5 and 12.5. In node 4, you have exactly one in link and one out link, so then the flow continue. Okay. Now to check in node 5, okay, the number of inflow 50, 25, 12.5, and 12.5 must be exactly the same as the outflow, yeah, which is 100. When this is correct, then this is ideal flow, yeah. This graphic number E here is ideal flow. To make it integer, you just divide by the minimum value, okay? So here I can divide by 12.5 all. I will get this is the integer ideal flow. Okay, so for your practice, I want you to practice manually. Can you do that in here? Assume probability distribution is exactly equal. What will be the value? And you can claim your recitation once you do it. Yeah, you can share your screen.
Any value, sir?
Any value, any value.
Any value. Can I do it, sir?
Sure, sure. I will stop sharing. You share the screen.
Sir, I'm just computing it in my mind.
Oh, okay.
Oh, okay, sir.
Great.
I'll try to Excel it also.
You can draw in paper if you want, or in the screen whiteboard if you want.
Whiteboard. How to access the whiteboard?
There is a whiteboard down there. Okay, I will open new one.
This one. Sorry. Ah, yeah, there. Sorry, sir. I wasn't able to see the
The whiteboard. Oh,
the example.
the example. The example is in the slide of IFN manual computation.
Oh, wait, sir. I have to
Wait,
open it.
if I can, let me check if I can copy and paste it here.
Yeah.
Okay. The whiteboard cannot draw. Okay, so you can
Also,
draw
sir,
any.
it has a prompt here that the owner of the whiteboard only allow sharing with users within the same
Really?
organization.
Wait. Why like that? New whiteboard. How to share the whiteboard? Share.
Oh, what slide again, sir, is that?
You can draw any network on your own here
Okay.
in the whiteboard. So let me draw. Can you do?
I can't.
You cannot. I'll share it to everyone. This is the link for the web. Why I cannot? Am I not the host? I'm still host. Editor. Is there any way to draw in the whiteboard? Hmm. Right. Is there any way to draw in the whiteboard?
Sir, I think you can share your screen, the slide, and then Resi will
Okay,
just annotate.
We'll just
okay,
annotate.
okay.
I think we can just
I will
annotate.
just share the slide. Maybe you can annotate here.
Okay.
Okay.
Wait, sir.
Okay, put any number here. Can you write?
Wait, sir. I'm trying to figure out how to actually annotate.
Any number that you want to put. Say 100. Where do you want to put
I'm
100?
new with Zoom. Where's the annotate?
Oh, annotate on the top. Yan it.
Resi, move mo lang yung cursor mo sa may PowerPoint, tapos may lalabas na sa lower left yung annotate.
Lower left. This one. Okay. This one?
There, yeah.
Yes. For example, let's start with the letter E here. We can put just for simple
Okay.
numbers.
Say,
We put
okay.
100 also. Going to
100.
A. Since we're moving in two directions, so that's
Okay. So 100 is for which one?
E going to A, sir.
E going to A. Okay.
E going to A. So from A,
That
since
means get
there's an
50 and
inflow
50.
of 100 and there is
Mm-hmm.
going an outflow of two outflows, two
Mm-hmm.
outflows or two direction, we just divided so we
Correct.
can actually
Correct.
50.
50 and 50.
And
Correct.
then in letter B, since
Mm-hmm.
you move there's an inflow from
Right.
A 50
Okay.
and we divided also again into two flows,
Correct.
going to E and going to C, so we got 25
Correct.
both directions since equal probability.
Correct.
Sorry, I'm just using my mouse pad.
Right.
And then going to C, we got 25, 25, and then since 25 plus 25 here plus 50, that's 100. So that's I think that's a constant. 25 here. Sorry, my handwriting is.
Okay.
That's it, sir.
Oh, you C to D is actually you need to divide by 2.
C to D, sir.
C to D because
Yeah.
D is
Sorry.
25.
Sorry,
Right?
I didn't see that.
Mm-hmm.
So yeah, we have to divide it also to 2. So I think that's 12.5 here. And then we got 12.5 here, and then since only one direction for D, 12.5, plus 12.5
Okay.
plus 25 plus 50, that's equal to 100.
Correct.
That's a equal probability.
Right. So you can, yeah, excellent, excellent. So you can actually compute the IFN manually, right? Easy? Super, yeah? So, right.
Thank you, sir.
Thank you, thank you. Where is my slide to show?
Sir, I have a question.
Oh, cool.
Regarding that. Are you familiar with the concept of residuals, or the one that, for example, from E to A, there is an inflow of 100, but it didn't reach the next destination. We actually
Okay.
call it residuals, or the
Mhm.
one that didn't meet or wasn't able to go to the next stations or to
Yeah.
the next nodes.
Okay. So, if you check if you check the book of IFN, okay, so you go to a place here. In Moodle, okay, on the top, okay, I have a reference here. Yeah, and then it will go to Google Drive. So there are 3 books here I put for you. Okay, and one of them is the book of IFN, and the other one is Modeling Transport by Altuzar. Okay, so so if you read this book, okay, there is that concept of residual inside in some part of that. Okay. Where the node is actually not the same. So this is almost 500 pages long. So you can just read on your own.
Thank you, sir.
Yes. Okay. Next. Okay, so you can already compute it manually. Okay. Okay, for the next practice, okay, to compute manually, can anyone compute this? Simple triangle. But this time, okay, not equal. The probability is not equal. So this is a T intersection, right? So going to the right is 2/3. Going to the left is 1/3 in node A. Can you calculate the ideal flow matrix? Anyone want to try? Annotate. Yeah, Andre, go. You annotate here.
So sir, let's say A is 33.
Okay.
So this is going to be 22.
22 and 11. Very good. And then down here is 22. And then there is 33. Very good. Now, then you divide all of this by the minimum. It is 11.
11.
Then you will
This is
get
going to
1,
be 3.
2, 3. Yes.
3, 2, 1.
Excellent. Correct. You see, yeah? So you will get exactly. How about this one now? Anyone want to try this? This is more complex.
How do I erase it, sir? I'm sorry.
Okay, I will stop sharing and share again. Okay. Anyone want to try this? It's getting more and more complicated. Given the different distribution, right? So yeah, this is one, but this is 1/3, 2/3, this is 1/4, and 3/4. Of course, the total probability must be one, right? So this is the stochastic matrix basically. So what will be the ideal flow matrix? You can compute by hand. Anyone want to take this challenge? Again, you can assign any number. So the easiest way to assign the number is actually the multiply this 4, the denominator, 4 and 3. That number you can use. So in that case, 12.
Sir,
Mhm.
can I
Sure.
share my screen?
Oh, sure. I will close this.
For a while, sir.
Mhm.
Oh God. Wait. Wait. Okay. Okay, sir. Wait. Ano ba to? Share. Ay, sir, can you... I think I'm not... cannot share my screen.
Oh, why?
Only the host can share this.
Okay. You are the host.
Okay.
You can share.
Can you see my screen, sir?
Yes. Okay. Oh, very nice. So
Sorry.
so
So I
one,
assigned 30 and then
how much do
2/3.
you set? 30.
Yes.
Okay.
So 30 thirds of 30 is 20,
10 and
1/3
20,
10,
and then
1/4 7.5.
wow, very complicated number.
And
20
then
going
smaller.
in.
10. Yep. 20 here. 20, 2/3 is 20, 1/3 is 10, while 1/4 is 7.5, 3/4 is 22.5, and so 20 plus the inflow for C is 20 and 22.5. So its outflow would be 42.5.
Okay.
And
And
then
then check. Can you check in each node? Yeah, can you check in each node? Is that correct? What is AB? What is AB?
AB is 10.
AB is 10. So
Yes.
10 here. And then, so going into node A is 7.5, but going out is 30. What is that? I think something is incorrect, Abdi.
Wait. Wait, sir.
Yeah, still not correct.
Okay, sir. I'll check again.
Okay.
That's
Anyone want to try? Okay, Mari.
Sir, I did what you said. So I multiplied 3 by 4. So for A, I used 12, and then 2/3 is 8. C to B is 8, 9, 3/4. And then 1/4 is 4. And then C to B is 8 because it's 2/3.
Do you want to share your screen so that we can
I
see?
use paper, sir. Maybe I can annotate
Okay.
I can annotate na lang
Okay.
in your slide.
Okay. I will share my screen. Okay. Here, and then I will share my screen. Can you see? Okay, you can annotate here.
Yes, sir. Wait. Where is annotate? Options. There. So I multiplied 3 by 4. So
Right.
this
Yes.
is 12. 2/3
Okay.
is 8.
Mm-hmm.
And then C, since this is also going in is the same as going out, so this is 8. And then 3/4
Mm.
is
Oh, no,
9.
not correct.
Why, sir?
Because this is
Because I have 8 going to C, so C to B must wait, yeah, I have 9 coming
there is
in.
PC here.
Yeah, there is BC and this is 4. So I need to get this one. I have 9. I have 9 and 8. That would be 17. So going out is 17.
How do you get 9?
12 divided by 4 is
No.
no,
Okay.
sorry. 3, I use 12, so 3/4 would be 9 because 4 times 3
Wait,
would be
wait.
12, right?
Okay, let's do this. In A, you assign 12, right?
Yes, sir.
Okay, that means 12 multiplied by 2/3 is 8. That's correct. AC is 8, right? And then this 12 you put in AB, how much? 4. Is that
I
correct?
did not for 1/3. I should have 4 also here.
Yes, 4 in here. Okay, so now can you delete this in BC yet?
Okay, sir.
This BC and CA you don't know yet. Also CB you don't know yet. So now you have 4 coming in, okay? And you don't know this and you don't know that. So you need to put a variables that you assume you know.
Okay, sir. I don't know how to delete it, sir. So maybe I'll just annotation.
Yeah, I
Okay.
cannot do annotation as well. Yeah, Resi, you want to say something or you want to share?
I mean, sir, sorry, I was muted. No, just after Gracie, sir, after her recitation.
Okay.
It's okay. It's okay. You can I know.
Yeah.
You can take over.
Okay, thank you. Sir, can you share again the screen?
Okay, sure.
So, what I actually did, since Andre used a 33 here earlier, I
Okay,
multiplied it by 4. So I got 132 here. So that if
okay.
the 1/4 of 132 is already 33. And then you
Okay.
got 22 here, and then also 11 here. And then the 3/4 of 132 times 70.75, that's 99, I guess. 99. Is it 99? Wait, sir.
132 times 3/4.
Yeah, times 3 divided by 4. That's 99. And then going here, 22 plus 19. 121 plus
99, 99
we
plus 20,
got 121 here, sir.
121.
So
Okay.
121 plus 11, that's
So
132.
now 132 divided by 4.
Yes,
That's
sir.
okay. That's
Yeah,
correct. So,
121
yes.
plus 11 here, that's 132.
Yeah, yeah. So good. That is correct. Let's see. So then you can divide everything with the minimum value, with this 11.
Thank you, sir.
Yes. Then you will get a very nice number with this one. Right. Okay, so at least you know how to compute manually the IFN, right? Okay. And from there, you can also make it very minimum. This is the minimum integer, okay, which is very nice, yeah. So you get 1, 2, 3, 9, and 10, okay, similar to your value a while ago. Yeah. This is what I call as equivalent IFN, okay. You can divide by the same scaling factor. Okay. I hope you understand that. Now, let's go to the next slide. Oh, where is the equivalent? Equivalent IFN. Okay, so can you see the slide? Okay, so a while ago, you see that when you have an ideal flow, okay, you can multiply, you can divide by the same scaling for the whole network. Okay, they are actually equivalent. So let's define it. Okay, so by definition, okay, so you have two network N1 and N2. Okay, they are two ideal flow network, right? So if the two IFN, yeah, is called equivalent if and only if, okay, each corresponding link flow of one network is a multiple of the other network, okay, by one global scaling. Okay, so you multiply by the same value of scaling, okay, then they are actually equivalent. Okay, so while the proof you can skip. Okay, so this is the example a while ago. Okay, so if you have assumed uniform distribution for this one, okay, and you can calculate the IFN, right? So, so which one is the IFN of this stochastic matrix? Okay, so here from A to B, okay, is 50-50. From B to C and D is also 50-50. And then in C is also 50-50, right? So which one is the correct one? Yeah. So first you can put 100 here, okay? And then from this 100 you can divide by 2, 50 and 50, right? And then now when you go to node B, okay, you don't know, because now you have two out link and then there is another in link here that you don't know the value. Okay. The same thing here when you go to node D, you have only 50 in, but you don't know VD. So in that case, you need to assume a value of X, for example. So I assume 2X here. Okay. because anyway, I will divide by 2, right? And from here, if I put this 2x coming in, okay, and then this is 50, that means I divide by 2, become 25 plus x. This one is also 25 plus x, right? Because they are equal probability. Okay. Now, this is now, I know this is 25 plus x. I don't know x, but I just put x, okay? And then here, 50 plus 25 plus x, that means 75 plus x, isn't it? Coming in. So that means here I know this is 75 plus x, okay? Then now you can put any x. Nah? For example, I can put x equal 50, okay? Then you will get this value if you simplify, yeah? If you divide by the value. So this one become 125, right? Then you divide by the minimum, yeah? Maybe you divide by 25, you will get this value, okay? Now, you can see that the IFN is actually not unique, okay? Okay, IFN is not unique in terms of the value, but for the same stochastic matrix, okay, the IFN itself is unique. If you put it into certain form, which is the minimum, okay, but you can multiply that value into with this global scaling. Okay, the one that Resi asking about a while ago is called local scaling, where there is a residual. Okay. Now, what is the implication? Yeah? The two IFN that share the same stochastic matrix, they are actually equivalent IFN. Okay. Now, if the two ideal flow network are equivalent, that means they also have the same stochastic matrix. Okay. So, this is interesting, okay, because now in each intersection, okay, we know, okay, how many percentage to go to the left and to the right, okay, or going straight, okay, within the same time period, which say within 1 year, they are almost the same. Okay, of you put that is the basic assumption here in IFN. Okay, the stochastic matrix are known and they are almost the same day to day. Okay, and then from there you can calculate the equivalent IFN simply by multiplying by a global scaling there. Okay, if you want to put it into integer, you do it into rational number with its fraction, and then you multiply with the least common multiple of the denominator. Okay, so we have several standard form. So if you divide everything with the total flow, we have the basis network. This link flow will represent as link probability. Okay. If you divide by the minimum flow, okay, that means the minimum flow will become 1. If you divide by the maximum flow, okay, the number will be from 0 to 1. Okay, the maximum flow will be 1. Okay. You can also have what I call as cardinal network. That means the link flow of all integer with is minimum. Okay. So the interesting things about equivalent IFN is this. Okay, they have, of course, by definition, they have the same stochastic matrix. Okay, but if you compute the coefficient variation of the flow, they are also invariance. Okay, and if you compute the average node entropy, they are also invariance. So I will show you in a moment. So, say for example, this is your flow matrix. Okay, so this is your flow matrix, and if you total, okay, this is in cardinal already, right? So the total is 38. Now you want to get the flow of 17,500. How do you get that? Easy, yeah? You get the scaling factor, which is what do you want, which is 17.5, for example, and then you divide by the initial, yeah, which is 38 here. Now you multiply everything in this flow network by this same scaling, so this by global scaling, then you will get the actual flow. Do you get the idea? You can linearly increase or decrease the flow simply by a global scaling. And you will see, okay, because you multiply by the same scaling, okay, they are still pretty much, yeah? See, here is 921.1, here is also 921.1. The total here is 2763, here is also 2763, and so on. Right? Now, in this example, okay, how we will compute into a cardinal network, right? So if you have the flow, okay, I make it into basis. That means the total flow is 1. And then I make it into fraction, okay? So if you look at this, if you put into fraction, okay, it will become divided by 49. So this is the global scaling. That means if you multiply everything by 49, you will get integer, which of course, the total flow will be 49. Is this clear or not? Okay. Okay, let's practice. Imagine there is a cloud node in the back. Okay? This network is not strongly connected. So there is actually a cloud node in the back that connect from the cloud node to this source. Okay, and then from this sink node to the cloud node. Yeah. So can you get the cardinal network of this IFN? What is the cardinal network? Okay, the value are integer, but that integer will be minimum integer. Anyone want to decide? You can annotate here. All you need to do is to get the global scaling. So say, for example, if I multiply this by 2, okay, I will get integer. It is minimum. Yeah. So you will see here, okay, the cardinal network, not necessarily, the minimum is not necessarily 1. Yeah. Is this clear or not? Any questions so far? Okay, this is another example. So which one is the basis network, and then how much is the scaling to from the cardinal network? Which one is cardinal network here? They are all equivalent. Yeah? The A, B, C, D are all equivalent IFN. Which one is the basis network? Basis network, okay, is when the total flow is equal to 1. Yeah, the total flow in the whole network. So clearly, network A is the basis network. Okay, this is represent the, if you sum, okay, all the link flow here, this represent link probability. Yeah? So the total is 1. Okay. Yes. Yeah, A is the basic network, correct. Katrina. So, and P here is the cardinal network. Yeah. So you multiply with how much? Yeah. From basic network to cardinal network, what is the multiplier? What is the global scaling? Yes, if you multiply everything by 18, okay, so then you will get this cardinal network, right? So from the cardinal network, you can multiply by 2, you will get C, okay? From the cardinal network, you multiply by 3, you will get T. So they are all equivalent IFN. Is it clear or not? Okay, the meaning of equivalent IFN. Okay, so you just, for the whole network, you multiply by the same scaling. That is how you calibrate actually in IFN. Okay, so with that, we can compute the, if you know the stochastic, okay, and then you multiply this is called entropy, okay, and then if you sum for all, you will get average node entropy, okay. And interestingly, okay, say you have this network, if you multiply by different global scaling, okay, you will get, of course, different average flow. You will get different standard deviation of the flow. Okay. But when you divide, okay, when you divide the standard deviation and the average flow, that is called coefficient of variation, you will see that the coefficient of variation for all this network, okay, they are equivalent network, okay, they are all invariant. Okay, you will have one number of coefficient of variation of the flow. This is very interesting. Yeah. Yeah. So using that, if you want to get, oh, I want to get the maximum congestion, you see here, this is important part of the IMN. Yeah. If you want to get the maximum congestion, then what you will do is actually find the global scaling. Say you have the capacity matrix, okay, you have the flow matrix, then you set the total flow is 1. From there, you can calculate the congestion matrix, right? Okay, and then you get the global scaling factor, okay, based on that K1, and then you can compute the new ideal flow matrix from the same capacity matrix with the different scaling only. From there, you can get the new congestion matrix. Okay, the maximum of that will be exactly what you want, the one that you set. Okay, based on this, okay, this is what the classical traffic assignment cannot do. Okay, what? You can compare two scenario, okay, before and after, or current condition and alternative without any data. Yeah, you don't have all the data, you don't have flow data, it's fine. You can assume global scaling, say maximum congestion of certain, say for example 0.8, and then you can compute the current condition. Okay, what is the maximum congestion? And then for the alternative proposed scenario, what is the maximum congestion? Then you can compare whether this is actually better or not from the current condition. Okay. This is the power of IFN, because now you can compare, because this is relative, right? So you can compare two scenarios without any data except from the network structure only. Yeah, this is what the classical traffic assignment cannot do, because they don't have global scaling. Okay, so okay, with this, I will stop here and you can actually do the assignment already in the Moodle, right? This one. Okay. So I will wait for your decision whether we will have a makeup class or not, one more. Okay. If not, then we will meet in January. Yeah. For those who want to have a rotation, you tell me.
Okay. Sir, for
Yes.
example, we opted to meet on the 21st, but some of us cannot attend. Will it affect their grade or something? Because I think
No.
we wanted to
It will affect
attend.
your recitation because you are the one who claimed.
Yeah, for example, but the recitation, it would take an effect if they're not going on the 21st. Because I think
No, there is no punishment on the if you don't come, okay? But of course, it will reflect on your recitation if you don't recite. Even if you come, but you don't recite, so it's the same.
um
Correct or not?
okay. Correct. But I think it will add into the total points, right? To the overall. If ever the one who got the highest, it will add to it to
Right,
her.
but that means you can catch up by recite more in the next class. That's fine also.
How about sir 27 after Christmas? Is it possible?
20
After Christmas.
after Christmas. There is no office. I cannot open the Zoom.
May
They
I
don't.
know within the class if there are Zoom Pro? Because we can make it on our own, I think.
I can make it on our own, but I don't know if they allow me to do it. So
Sir, okay.
that's the problem there.
Okay. So we'll discuss it first again with the class.
Yes.
Because
So
majority of us can attend on the 21st, but I think three classmates or four is not going.
okay.
So we have to discuss it again.
Okay. So you tell me later about the decision.
And as for the exam coverage of the final exam, all of us voted for after the midterms,
Okay.
the lecture
When is
after the mid.
so that means from third generation.
Yeah. Yes, sir.
Okay. So that will not include regression or include regression.
Regression.
How about forecasting and regression? Do we need to
It's
include
not
or not?
included in the midterm, right? The regression.
I forgot. So
And
okay, so let's put it this way. So let's start from transport demand analysis. Is that okay?
Okay, sir. Better than cover to
Okay.
cover.
Okay, so this one from the beginning until here is not included. So from transport demand analysis until the end. Right.
Right, sir.
Okay.
Oh,
Thank
so
you.
does it mean it includes the green shields, right, sir? So meaning the green shields.
Green shield and BPR is included because whether you like it or not, it's part of the
The succeeding topics. Okay.
right.
Copy. We can take green shields.
You cannot avoid that.
Okay, sir. Noted.
Right. Yeah. Thank you. Thank you for today. Okay.
Thank you, sir. Good night.
Good night.
Thank you, sir. Good night.
Good night.